Hello listeners and viewers. Welcome to Kaduna State Ministry of Education Radio and TV e-learning program designed for our SS3 and other students staying at home due to the coronavirus pandemic. The present administration, under the able leadership of His Excellency, Malam Nasir Ahmed El-Rufai, is positioned, as always, to ensure that under his leadership, our students are not left behind in all areas of human endeavors, especially education. Kaduna State is the center of learning. Therefore, we want to ensure that our students excel in their forthcoming examinations and beyond. Students and other learners at home are given this opportunity in order to continue learning, as education is a continuous process. Different subjects will be taught in this program to assist students to perform excellently in the forthcoming Senior School Certificate examination being conducted by NECO and WAEC as soon as schools reopen. Teachers making presentations will always provide their names and phone numbers during each presentation, and they can be contacted for questions, further explanations, and/or clarifications. The following numbers and contacts can also be reached for expression of any concern or observation: 090-865-00545 or 080-383-62072. Our website is www.education.kdsg.gov.ng. Our email education@kdsg.gov.ng or education.kdsg@gmail.com. Our YouTube channel, Ministry of Education, Kaduna State. Our Twitter handle @Kaduna_MOE. Or our Facebook page, Ministry of Education, Kaduna State. Stay safe, stay at home, and learn well. Thank you, happy listening, and happy viewing.
Hello and good day, my wonderful students. Today again we will be discussing chemistry under the Ministry of Education Kaduna State e-learning platform. Our topic has been a series on acid, base, and salt. Today we'll be concluding this lesson and we'll be discussing salts. When you say salt, what comes to mind ordinarily is the table salt that you use for cooking at home, or the table salt that you use for seasoning your food. But in chemistry, we have different types of salt. We'll be looking at our discussion based on the definition of salt, types of salt. As you can see numbered, we have method of preparation of salt, uses of salt, buffer solution, features of salt, and lastly, water of crystallization. Now, under the introduction, like I was saying earlier on, when you say salt, what comes to mind is that thing that you use for seasoning your food or to make your food tasty. But in chemistry, we have different types of salt. As you can see them in their colors and texture. You can see yellow, green, and so on and so forth. So apart from the salt that you use for cooking at home, there are so many other types of salt. So what is salt? Today you'll be learning what a salt is. Now, to define a salt, we say a salt is any substance that is formed when the replaceable hydrogen atom in an acid is completely or partially replaced by a metal or ammonium ion. Like I said, a salt is any substance that is formed when the replaceable hydrogen atom in an acid is completely or partially replaced by a metal or ammonium ion. As you can see in my example, you can see an acid HCl, hydrochloric acid. When you replace the hydrogen in HCl with a metal, the metal can be sodium for sodium chloride, potassium for potassium chloride, calcium for calcium chloride, and ammonium for ammonium chloride. By that, you have replaced the replaceable hydrogen atom in an acid by a metal or ammonium ion. You can see another example, tetraoxosulfate 6 acid with 2 hydrogen atoms there. And you can see it when you replace one of them with sodium, you have sodium hydrogen tetraoxosulfate 6. Or when you replace the 2 of them with sodium, you have sodium tetraoxosulfate 6. As the case may be, you can also see potassium hydrogen tetraoxosulfate 6 or potassium tetraoxosulfate 6, exhibiting that these hydrogen ions can be replaced partially or completely. Now, in our next discussion, we'll be looking at the different types of salt. We have 5 basic types of salt, and their names are normal salt, acid salt, basic salt, double salt, and complex salt. As we go on, I will explain these types of salt one after the other and with examples. The first one is the normal salt. The normal salt is formed when all the replaceable hydrogen atoms in an acid are completely replaced by a metal. And it can only be achieved when there is sufficient base to completely neutralize the acid. So you can see from what we have here that HCl reacting with sodium hydroxide, it will give you sodium chloride plus water. You can see in sodium chloride there is no hydrogen atom, meaning that all the hydrogen atoms have been replaced completely, and sodium chloride is a normal salt. Other examples of normal salts are sodium tetraoxosulfate 6, potassium tetraoxosulfate 6, potassium chloride, calcium chloride, just to mention but a few, meaning that you have so many other examples. If you lay your hands on authorities, your books, you'll be able to come up with so many other examples. Now, another type of salt is acid salt. An acid salt is formed when there is a partial replacement of the hydrogen atom in the acid by a metal. When there is a partial replacement, when I mean partial replacement, it means when the hydrogen atom in the acid is not completely replaced. And this is only possible when there is insufficient base to completely neutralize the acid, when the base is not enough to completely neutralize the acid. So you have the formation of acid salt. If you look at the example here, you find out that H2SO4, which is tetraoxosulfate 6 acid, reacting with potassium hydroxide. Now, one potassium replaces one hydrogen. So you can see there is still one hydrogen in that salt, and it becomes potassium hydrogen tetraoxosulfate 6 plus water. The presence of that hydrogen there indicates that it is an acid salt. Remember I said an acid salt has the replaceable hydrogen atom partially replaced, not completely replaced. And I can also go ahead to say acid salt can further undergo neutralization reaction to form a normal salt, meaning that if you add more base to the reaction, a normal salt will be formed, so that you can see the acid salt there, potassium hydrogen tetraoxosulfate 6 plus the base potassium hydroxide. You can see here the hydrogen atoms is completely replaced and it becomes a normal salt. So other examples of acid salts are sodium hydrogen tetraoxosulfate 6, potassium hydrogen trioxocarbonate 4, calcium hydrogen trioxocarbonate 4, and so on and so forth. My wonderful students, I know you've been enjoying this presentation, and chemistry is usually very, very interesting to listen to. Just exercise more patience as you'll be getting more tips on what a salt is. Now, the next type of salt is a basic salt. Like the name implies, it's formed when there is insufficient acid to completely neutralize the base. A basic salt is formed when there is insufficient acid to completely neutralize the base, such that if you look at the example I have here, I have zinc hydroxide. Now, the hydroxide, which is the OH group, is the characteristics of the base, such that if hydrogen replaces chlorine, their chloride there, replace one OH, you have zinc hydroxide chloride. And that hydroxide in the salt there makes it a basic salt. It makes it a basic salt, meaning that that salt still have a quality of base in it. Now, the basic salt can further undergo neutralization to give you a normal salt, meaning that if you add more acid to the reaction, more acid to the reaction will lead to the formation of a normal salt. So that zinc hydroxide chloride plus hydrochloric acid to give you zinc chloride, which is a normal salt, plus water. Now, after basic salt, we have double salt. Like the name implies, double. A double salt is made up of two simple salts. And you can do it by double salts are formed by crystallization from a solution containing two salts. Double salts behave in solution as a mixture of simple ions. Now, these double salts have two cations, as you are going to see later. And when you mix this salt, usually a hot, concentrated, equimolar solution of two salts will give you a double salt. I said that of which they are composed, and double salts are composed of two cations. Remember, I mentioned that earlier and said they are prepared by mixing hot and concentrated equimolar solution of two simple salts. Equimolar here implies to equal concentration as regard to molar concentration. So some examples there are, you can see iron ammonium tetraogosulfate 6, which is a double salt. Majorly, our alums, the alums that we use are double salt. And you can see that the alum you use for coagulating your water during water treatment is potassium aluminium tetraoxosulfate 6 dodecahydrate, and that is the 12th water of crystallization in that substance. So it's an example of a double salt. The two cations there are potassium and aluminium. Now the other one is complex salt. Like the name implies, it's a complex situation, and we're not going to talk too much about it, but I'll just let you know that a complex salt is made up of a central metal ion. This central metal ion is usually a transition metal and is surrounded by ligands. And your ligands can be your water, your cyanide, just to mention but a few. So if you look at it, complex salt usually contain complex ion. And complex salts loses their identity in solution. It means that when you put a complex salt in water, all the ions will go their separate ways. They no longer behave as an entity. And that's what we mean here by they will lose their identity when in solution. Example is potassium ferrous hexacyanide. Potassium ferrous hexacyanide. And you can also see copper 2 tetraamine tetraogosulfate 6, as the case might be. So these are examples of complex salts as we have been following. My wonderful student, it's a very simple topic, and I'm sure that if you pay attention, you'll be able to grasp it 100%. And when you do that, it will be at the tip of your fingers when question comes in your examination, and you'll be able to carry out the answer smoothly. Now, the method of preparation of salt. There are several methods of preparation of salt, but we are going to group them into two top topics. Method of preparation of soluble salts and method of preparation of insoluble salts. If you have followed our class earlier on, you will have seen we have mentioned how salts can be prepared when we are discussing acid and also when we are discussing base. Now, one of the methods of preparation of your salt is by direct action of some metal with acid. Direct action of some metal with acid. Example of such metal is zinc. When you plus zinc with hydrochloric acid, you will get zinc chloride and hydrogen gas will be liberated. And what do we mean by some metals? It means those metals that are above hydrogen on the electrochemical series. Meaning that metals like copper, platinum, mercury, silver, and gold cannot displace hydrogen in a reaction. Like this. Now the other one is action of insoluble base on acid. Remember in our last class we told you that base can be soluble and insoluble. An example is copper oxide. When you react copper oxide with hydrochloric acid, you will get a salt, copper chloride plus water. And the next one is action of trioxocarbonate 4 with acid. Remember we said when trioxocarbonate 4 react with acid, carbon 4 oxide is always liberated. And so in this reaction, lead 2 trioxocarbonate 4 plus trioxonitrate 5 acid, which is HNO3, will give you lead 2 nitrate plus water plus carbon 4 oxide that is liberated. Remember I said carbon 4 oxide is a gas that turns lime water milky, and it's an acid anhydride. It dissolves in water to give a weak carbonic acid. Now, my students, you find out that we'll be talking about method of preparation of insoluble salts. Now, those salts that are not soluble, how can you prepare them? Of course, okay, it's a continuation of method of preparation of soluble salts. So we have neutralization reaction. In my last class, I said neutralization reaction is a reaction between an acid and base to give salt and water only. And by that definition, you find out that during neutralization reaction, salts are usually produced or prepared, as the case might be. Looking at the equation, you have an acid HCl, you have a base potassium hydroxide, then of course the salt is potassium chloride plus water. Now, when you are preparing your insoluble salt, this is very, very important when you are carrying out your qualitative analysis. You find out that precipitate will always come out. Now, these precipitates are usually insoluble salts, and these insoluble salts are prepared by precipitation by double decomposition. And I give you an example of that. You see that calcium trioxonitrate 5 plus sodium tetraosulfate 6 to give you calcium tetraosulfate 6 plus sodium trioxonitrate 5. Now, what happens in this equation is that each of the reagents will decompose, and of course they will exchange their anion. You can see that the anion of calcium trioxonitrate 5 comes to sodium, and the anion of sodium goes to calcium, and that is what we refer to as double decomposition. And these precipitates are formed as insoluble salts. My students, how time flies. I'll be looking at the uses of salts. How do we use salt? I know if I ask you that question at home, what will come to your mind is that these salts are used for cooking. But apart from cooking, there are so many other uses of salt. You can see that sodium chloride is used as table salt. Salts are used in fertilizers. Example is potassium trioxonitrate 5. Then we have ammonium trioxonitrate 5. Then magnesium tetraosulfate 6 is used as laxative, and liver salt when your stomach, you understand what I'm saying. Then we have calcium trioxocarbonate 4, which is used in the manufacturing of salt. Of course, salts of silver halide are used in photography. And lastly, alum is used for coagulation in water treatment, and copper 2 tetraosulfate 6 is used in the treatment of swimming pool. And that is why the water in swimming pool will always look blue in color. Buffer solution. A buffer solution is a solution that resists a slight change in pH when an acid or base is added to it. And they have conjugate base and conjugate acid. Example of buffer is ethanoic acid and sodium ethanoate. So many other examples like ammonia and ammonium chloride. Now, these salts have features, characteristics. It can be hygroscopic, deliquescent, or efflorescence. Now, what is the difference between these three? Hygroscopy is a phenomenon that exists when substances that are exposed to the atmosphere absorb moisture but does not turn into solution. When substances that are exposed to the atmosphere absorb moisture but does not turn into a solution, and they are called hygroscopic substances. You can see example is calcium oxide, concentrated tetraosulfate 6 acid, and copper oxide. The next one is deliquescent. Deliquescent is slightly different because it's a phenomenon that exists when a substance absorbs moisture from the atmosphere and turns into solution. When a substance absorbs moisture from the atmosphere and turns into a solution. Now, examples are magnesium chloride, calcium chloride, sodium hydroxide, potassium hydroxide, etc. My wonderful student, note that when you expose substances to the atmosphere, when they are hygroscopic or deliquescent, they will increase in mass because of the water they have absorbed, and they are usually used as desiccant or drying agent. Little under, when you buy a leather shoe or bag, you find a tiny material in an envelope in that bag. It's written silica gel on it. It's usually a desiccant or a drying agent. So the efflorescent is different from these two, and it's a phenomenon that exists when a substance that is absorbed to the atmosphere loses part or all of its water of crystallization. As you can see the case here, we have iron 2 tetraosulfate 6 heptahydrate. We have sodium triiosocarbonate 4 decahydrate, sodium tetraosulfate 6 decahydrate. These are all efflorescent salts. Lastly, my students, water of crystallization. What is water of crystallization? Water of crystallization is a definite amount of water molecule or a fixed amount of water molecule contains in 1 mole of a substance. And as you can see, copper 2 tetrasulfate 6 contains 5 molecules of water of crystallization. And that's why we call it copper 2 tetrasulfate 6 pentahydrate. In exams, students can be asked to differentiate between hydrated salt and anhydrous salt. The difference between them is that hydrated salt contains water of crystallization and anhydrous salt does not contain water of crystallization. Time has come for me to go. I wish I can stay longer, but I'm sure my colleague he will come here, Mr. William Ishaku, and he will make this class more lively. Stay safe, read your books, and you will get an A in your exam. Thank you.
Hi, my student. Once again, I'm glad to see you. My name is Williams Ishaku. I'm here to review the presentation, beautifully presented by my able colleague, Mr. Philip Mamman. You will recall that we're talking about acid, bases, and salt. We've said a lot about acid, bases. Today we're here to discuss about salt. Under this topic, he told us that what is salt? We started by the definition of salt. We say salt is any substance in which the hydrogen ion has either been partially or completely replaced by a metal in an acid. However, this salt can be categorized based on whether the hydrogen ion has been partially replaced or completely replaced. By that, we have different types of salt. We have the normal salt, the acid salt, the basic salt, the double salt, in which he gave you all their examples. For the normal salt, all the hydrogen ion has been completely replaced by the metal. For the acidic salt, it's partial. And for the basic, the acid is not enough to neutralize the base, and so therefore, we still have some quantity of hydroxyl ion. Therefore, we have the basic salt. The double salt, the coming together of the two salts to form the double salt. The complex salt we know is as a result of the formation of ligands with complex metals. However, there are various methods we can use in preparing this salt. This salt can either be soluble or insoluble. For the soluble salt, we were told that we can use method like direct reaction of heavy metals with mineral acid to give us salt like zinc chloride. We can also use neutralization reaction, a reaction between an acid and a base to produce salt and water. The salt, we evaporate it and then get our salt as normal salt. Again, we have double decomposition, which can be used in the preparation of the insoluble salt. He made mention of so many methods that we can use. This is just to mention but a few. Coming to think of the uses of salt, of course, salt have so many uses. We can use them as table salt in our respective homes. In the manufacturing of fertilizer, we can use salt in the treatment of our swimming pool. We can use salt in manufacturing so many things, preservation of so many materials. This is just to mention but a few from those things he has mentioned. Again, my student, he said, when we are talking about salt, we have other salts that are resistant, that they don't show any change, or they seem to be resistant to any change in pH, even when an acid or base is being added to them. Sometimes if you add an acid to some of these salts, you are supposed to have a change in pH. But there are specific salts that tend to resist such changes. Such salts are described as buffer solution. He gave us example of buffer solution, a combination of weak acid and its conjugate base. And then we move along again, he gave us features of salt. What are the characteristics of salt? Each time we are talking about salt, a salt could be hygroscopic. What is hygroscopic salt? Any salt which when exposed to the atmosphere, it will absorb moisture but will not form a solution. But for the deliquescent, it will absorb moisture and it will form the solution, whereby the efflorescent, when exposed, it will lose its water of crystallization. My student, I believe With this, you have learned a lot. Stay safe and remain focused while you learn. May I, at this juncture, invite my able colleague, Mr. Ibrahim Umar, to come forward for the assignment. Thank you. See you another time.
Hello, my wonderful students. I believe you've learned from the presentation, wonderful presentation from Mr. Philip and Mr. Williams Ishaku. I'm here to give you sample questions, study questions for you to study at home. The assignment questions are as follows. Number 1, A. Define desiccant and give 3 examples. Number 1A. Define desiccant and give 3 examples. 1B. Differentiate between hydrated salt and anhydrous salt. Question 1B. Differentiate between hydrated salt and anhydrous salt. Question 2A. List the types of salt with 2 examples each. List the types of salt with 2 examples each. 2B. Define basic salt. Question 2B. Define basic salt. Question 3. Differentiate between the following. 1. Hygroscopy and hygroscopic. I'll take it again. Number 3A. Differentiate between hygroscopy and hydroscopic substances. B. Deliquescence and deliquescent substances. C. Efflorescence and efflorescent substances. And then question 4. Define indicators and give 3 examples of indicators. I'll take the questions again. Question 1. Define desiccant and give 3 examples. 1B. Differentiate between hydrated salt and anhydrous salt. Question 2. List the types of salts with 2 examples each. 2B. Define basic salt. Question 3. Differentiate between A. Hygroscopy and hygroscopic substances. B. Deliquescence and deliquescent. C. Efflorescence and efflorescent. And then question 4. Define indicators and give 3 examples each. My wonderful students, I will give you reference materials in case of further questions. If you want to study further, we have 1. Understanding Chemistry by Godwin O. Ojokuku. We have the New School Chemistry by Ese Wiao Ababio. We have the STAN Chemistry textbook for SS1, which is by the Science Teachers Association of Nigeria, STAN. You can even consult other textbooks apart from the one that are indicated. And in case you solve the assignment or you have further questions, you can contact any one of us using the following numbers. Philip Mama, 08026598861. Ibrahim Omar, 07036202842. Williams Ishaku, 08160670920. The number again, Philip Mamman, 08026598861. Ibrahim Omar, 07036202842. And of course, Williams Ishaku, 08160670920. Thank you very much, students. Stay at home, stay safe, and then keep learning. Goodbye.